I don't want to misrepresent hand-wired amps as being the apex of effort and skill, and diminish the mastery of good PCB design in the process. To design an effective low-noise circuit with either of these methods requires very different but equivalent knowledge and expertise. However, it is much easier to look at the hand-wired amplifier and see the effort displayed visually in the assembly of the circuit. Even if you know nothing about electronics, when you look at this, it's obvious to see where the effort went in the construction and find it impressive. Whereas PCB looks like a PCB, no different to the hundreds of identical boards that were machine assembled and rolled off production line the same day. That tends to have people interpret PCB amps as lower effort or less skillful than their hand-wired counterparts, but that's not true. The hours of human effort spent on PCB is in the design phase, where engineers sit in front of PCB design software, agonising over trace widths, clearance, via diameters, ground fills, and many other factors that need to be considered to ensure issues don't arise with signals and powers travelling through the copper traces. We talked about how, with hand-wired design, power wires need to be routed away from signal wires to prevent the electric fields interfering with the weak signals. And that same physics is true for PCBs. Power traces need to be wider to carry the required current, but they can't be placed parallel to signal traces for the same reasons of electric field interference. It's just easier to see in a hand-wired amp the twisted pairs of power wires being routed around the chassis perimeter than it is to identify differences between green traces on a green board. And with everything being packed much more closely on a PCB, these design challenges become much trickier. PCB does have its physical limitations, but so does hand-wired. And so long as each is designed or constructed properly by people who know what the fuck they're doing, there shouldn't be any vast observable difference in their sound. I'm pretty confident in saying that if you took this circuit and redesigned it to work on a PCB, you could play these side by side and not be able to tell one from the other. Especially once the guitar has gone through your instrument cables, maybe a couple of pedals, the amp, out to a speaker, into a microphone and back through a PA system. At that stage, are we really noticing the difference between electricity going through point-to-point component legs compared to a copper trace? I'm not saying these two things behave necessarily identically on a subatomic level, but given the whole context of the system, any variances are so small as to be negligible.